Morning, everyone.
Morning, doctor. Good morning.
How are you?
I'm good. How are you, doctor?
Fine. Thank you. How's weather over there?
It's hot here, doctor. It's very hot.
Oh, really? Okay.
Yeah. At daytime, it's almost 39.
39. Wow.
Yeah. Normally 39 nowadays. So without aircon, you can't sit.
Oh, really? Okay.
Yeah.
Malaysia is sometimes rain, sometimes sunny, something like that, as usual.
Yeah, nowadays, but here it is because these months like May, June, July, these are the months which are really hot here.
Okay. You got snow there?
Snow, not in my city because my city is near to the sea.
Okay.
So snow is in the north actually. There is in Pakistan. You will find it in north.
Okay. You are right. Okay. Okay, today we will continue from the yesterday's. This is example, yeah, example 7.4. You can find it in your book. Okay, someone join in. Okay, so we have a simple plan. We have discussed this plan yesterday, but in this example, we design BC12. Yeah, we need to design this panel. You can see this panel. This panel, yeah. Okay. So what like what we have discussed yesterday, the first is that you need to think how are we going to design this slab. Yeah? So we need to identify what the type of the slab. Yeah? So here we found that this is discontinuous edge, yeah? And this one is also continuous edge. So, someone want to join in? Yeah? Okay, so this is T4. Yeah? Okay, after that, once we establish the type of the slab, so we need to find what is the moment. Then we need to think about the arrangement of steel before we start the design. Okay. So here I already, although yesterday we already discussed, yeah, but yesterday we discussed if at the moment for the whole slab, right, in the cross section X and Y. But today we concentrate on one panel. Yeah? So in the exam, maybe the question asks you to design for a cross section that yesterday we have discussed. Yeah? Or maybe the question asks you to design one panel only. Yeah? Just like this example. So if one panel only, meaning that we need to design only that panel. So we concentrate to BC12. So we have already know that it is T4. Yeah, so it is T4. So this is two edges and edges discontinuous. And now the L over Ly over Lx is 1.75. Yeah. 1, 2, 3, 4. So here 4. So we have 1.75. 1.75. So we have here 1.75 and this one. Okay. So like yesterday's, I think if you get used with this table, so we just need to find what is the moment at this direction. Yeah. So So moment at this direction, this moment, right? This direction. So here is 0. So we have moment at midspan, at y direction. This is ly, and this is ly. Ly is 7 meter, and then moment at this direction. So I guess everybody know how to determine this value. So this is ly. So ly meaning that it is bsy. So negative moment here is 0.045. Right. Then 0.034 here. 0.034. Okay, and then another thing is that we need to find the moment at the opposite direction here. Sorry, I need to change other colors. So here the value is 0. It is positive moment 0.065, 0.065. Then the moment here. So it is, the value is 0.087. 0.087. So we don't bother from the other panel because we want to design only BC12. So this is the value that we need to consider. So we have moment at this direction, x direction. Before always, before you start design, always imagine the bending moment. So we have bending moment like this. Okay. And then bending moment. So we have moment here with the bending moment. Okay, 0 at the support. Support here is 0, and then we have here moment. Okay, so this is the moment. So what is the moment here is MSY, y direction is equal 0.034 and Fazrin Yauzi. Okay, so moment here is 0.034. Just now. Okay, sorry about that. Okay, so we have n 0.034 and lx square. Okay, and then for the support, so at the support here is 0.0. MSY is equal 0.045 and lx squared. Okay, so you need to imagine the the moment diagram for the slab. Yeah, because now we have two-way slab, so we need to design both ways. Okay. Okay. After that, all right. Let me erase first. Okay, once you got the moment, yeah, so you need to imagine how are you going to arrange the steel, yeah. Just now we have, this is LX, yeah, so meaning that we need to design this direction 1 meter width, yeah, 1 meter width here, okay, 1 meter width only, design for 1 meter width only, and then we produce the cross section. Yeah. So actually we design for 7 meter, but we design for 7 meter width, but the calculation is based on 1 meter width. Yeah. So this is the main direction. Yeah. This because this is LX. Yeah. You can see here. Okay. Since this is LX, yeah, this direction is LX. This is LX. Okay, so this is the cross section at this slab, yeah, cross section. So this is the cross section of the slab. So this is the cross section, the yellow figure here. So this is the cross section of this slab. So we have here, this is the beam to represent this bold line here is the beam, and this is the slab, and this the beam. This one is represented by this beam. Yeah. So before you design, you need to imagine. Yeah? So we have a. How do we end the show? Yeah, it is this. Right? So okay. So the steel, yeah, the steel. We must arrange the steel as I show you just now. Yeah. So the steel must be the main steel shown by the red one. Yeah? The red one is the main steel obtained from the moment at X direction. Yeah. Just now remember you got moment from the moment, yeah, we obtain the moment, that is the moment, okay, and here, okay, so this moment, yeah, the moment here, MSX, okay, will at the near middle end span, okay, will produce the red color, yeah. So meaning that the steel obtained from MSX must be located at the bottom, yeah? The bottom part. Yeah? This is the bottom part. You can see. Yeah. Sorry. Okay. Here, this is the bottom part. Yeah? The bottom part here. This is the top face of the slab, and this is the bottom face of the slab. And MSX near at middle span must be located at near to the bottom face of the steel. Yeah? The red one is obtained when we design at the span. Yeah? And the blue one is the steel from the y direction of the moment. Yeah? Because we have y direction, this is x direction, just now we got y direction. So this first. Show you the y direction. We have y direction moment. The y direction is like this, yeah. Okay. Sorry. So I need to draw somewhere here, yeah. Where is it? The line. Yeah, let's say this is 1 meter width. This is represent 1 meter width here. So the moment is just like that. Okay. This representing the 1 meter width here. Yeah. So this is MSY. So because this is y direction, this is y direction. So the steel that we look from this direction, we look from the x direction, it will be located on top of the x direction. The dotted, the dot, you can see the dot in blue color here is the steel obtained from this moment, my. Therefore, when you draw the steel at y direction, you can see that as shown in this figure. The blue one will be located on top of the x direction, while the x direction from this cross section you can see it is dot, dot shown by here, the dot in red. So the dot in the steel represented by dot in red is in y direction. Sorry, x direction, meaning that, okay, sorry, I have to choose blue, the blue, okay, blue color representing the y direction. So the y direction will be put at the here, something like that, yeah. And then the red direction, the steel in red here, this is the x direction, something like that. Okay, this is from the plan, yeah. Okay, and then another thing is that we have the moment here, right? So moment here, moment at the support here, yeah. The moment at the support, we will get another steel. And the steel, the main steel, yeah, will be located here, something like that. Yeah. This is from the moment from the support. Yeah. If I can draw here something like that, yeah, the moment. Okay. So here, the steel. When we design this moment, we will provide here, something like that, yeah. And from this moment, we get this, all right. For the blue one, yeah, the blue one. When we design this moment here, we get this one, this steel, all right? And now we need to consider the moment at this support, yeah, we get the steel, right? So we will also provide the steel here. Sorry, it is a line. And that is given by this moment from here to here. Okay, so to design for this slab, for this panel, this panel that we considered, we need to design how many moments? 1, 2, 3, 4. 4 moments. That is moment for the X direction. We have near at middle and span, and also at the support, and at Y direction also near middle and span, and also at the support here. So we have 4 moments. Okay, so that is the steel that we considered before you start design. It is better for you to understand the steel arrangement so that you got peace of mind during the design.
Doktor,
Ya.
ada orang nak join tapi
Ada
tak
sudah.
dapat masuk. Okey.
Okay. Yeah, that is the main steel. That is the main steel. Okay. And then the torsion, right? Last time, yesterday I talked about torsion. Torsion. So to avoid the torsion, we need a steel at the top face, like that. Okay, you can see that one. Okay, that is to avoid torsion or lift up at the corner. And also this face, we need to put another steel at the top face. Okay. Okay, any question? Ada soalan? No question at all? Okay, if there's no question, then we need to proceed with the design. Okay. Okay, look at the data given. Always look at the data given. So the given data is the permanent GK. This is excluding self-weight, meaning that the thickness of the slab is not included. This is mainly from the shielding and also the tiles. GK here. Variable QK, this is the QK according to the purpose of the building. Design life 50 years. For the building it is 50 years. Fire resistance are 60 minutes. Exposure classes given here XC1. Okay, characteristic concrete FCK 25. Someone to join. Nurul Asfarina and Andy. Okay, the unit weight of concrete 25, and the bar given is 10 millimeter. So design BC12 with the long span and short span. Okay. Since the question here, the thickness is not given, so as usual, we need to find the thickness. So in order to get thickness, we have two methods. The first method is by determining the minimum thickness of the slab according to the fire resistance. Therefore, we need to refer to the code or the design formula given to you. So the thickness, let us see. Okay, this is minimum cover. This is exposure. This is bond. Simply spotted. Okay, yeah, table 5.8. This table, minimum dimension and exit distance for simply spotted one-way or two-way slab, solid slab. So our one is two-way slab, yeah, two-way slab. So if it is 60, yeah, the thickness is 80. Yeah? The recommended thickness is 80 for the fire resistance 60 minute. And the value of A is 15 millimeter here. So we have this is for the cover calculation, but now we need to find the slab thickness. So it is 80. So this is 80. Therefore here we got 80. And then estimate thickness considering the deflection control. As I said last time, H, the deflection control, yeah, is between 20 to 30, okay, but here we try 35. This is only the estimation, yeah. So if you like, you can change to the 30. That is rule of thumb. So you can use 35 or 30. Okay, let's say if you choose 30, so what happened? Is 133, yeah, so you need to change here 150, yeah. Okay, all right, because the rule of thumb is 20 to 30, but if you want to choose 125 is okay. You can change it later if the cracking is not, not safe, yeah? But let's say now we stick to the our guidance 20 to 30. So we have 150 here. Okay. So 133 and 80. So we got two values here. So we must select the higher between these two. So it is 133. So the nearest 133 is 150. Then the second step is the covers. Since this question is the cover is not given, but the exposure class is XC1, so that we can calculate what is C. As you know that C will be determined according to the three guidance. The first guide is that bonding. Yeah. So if your steel will be arranged in the separate ways, the minimum cover to make sure that it is safe from bonding is that cement must be equal to the size of the steel. So here the size of the steel is 10 millimeter. Yeah, if you forgot, then just go to the here your guideline formula. Guideline here, minimum cover for the bond, it is separated, it must be equal with the diameter, yeah, if in bundle, yeah, for example in the beam. So we need to consider also whether you want to arrange the bundle, yeah, but for the slab it will be arranged in the separated ways. Therefore it must be equal with the diameter of the steel. And then the second one is minimum cover due to durability. Yeah, durability, our durability is XC1 here, XC1, and the strength of concrete is 25. So let's see from the table here how to get the 15. Okay, so refer straight to the 4.3. Yeah, okay. Bear in mind that what we need to find is that the S, what is our structure class. Although building is S4, but we must consider also table 4.3. Given is S4, right? So default for the building is S4. But when you want to find cover, we need to refer this table first. Yeah? So we need to find what is the new S. Yeah? Therefore, what we're going to do is that take the number of 4. Yeah, S4, the number 4. And then see table 4.3. Is it any correction? Yeah? According to this table, the first correction is that here we now we are using XC1. The first correction is that if your design working life 100, so you need to minus 2. Yeah, but our design working life is 50, so we don't need to consider this. Yeah, we don't consider this. The strength, our strength is 25, so we don't need to consider this one as well. And then member with slab, yeah, because we are designing slab, so we need to consider this correction, so minus 1. Okay. Then special quality control, also we don't consider. If you do, then you need to minus 1. Let's say we don't consider the quality control, so we have 3. Therefore, our new structural class is S3. Okay. Then after you got this one, the answer, go back to the table 4.4. S3, yeah? So our one is S3 here, S3 and XC1. So we have a 10 here, yeah, 10, not 15 but 10. Therefore, go back to our calculation here. Here is 10. Okay, now A. Okay, remember just now we obtain to get the minimum cover due to fire, we need to obtain the A. Yeah? Okay, A is 15 here. Okay, the value here 15 due to R60. Okay, now we have 15. Okay, back to our here. Okay, 15. We got right value here. 15. Then by using this equation, 15 minus diameter bar divided by 2, so you got C min is 10 millimeter. So we have the value, all the value from these three C min is 10. Therefore, our C min is 10. If you got different value, then we just use the highest one. So therefore, our C norm is C min, the highest value within these three, 10 plus deviation. Yeah, here 10 also. So you got 20. Therefore, to the nearest 25, so we use 25 our C norm. Okay, now we have C norm already. Now the next step is that action. Yeah, N. N is the action on the slab. So the value is 1.35 GK plus 1.5 QK on the slab. Yeah? Don't think about the beam. We are now designing the slab. Don't get confused with that. Therefore, N GK on the slab is due to self-weight from the shielding, from the tiles, yeah, that is given just now. The value is 1.5. Then our slab width is the thickness of the slab times with the density of concrete. So we have 3.75. The unit, make sure that the unit is same for both. Yeah? So we got 5.25 kilonewton per meter square, and the variable action is 4. So you got now N design action 13.09. Okay. Then do the analysis. This is the moment just now that we discussed, and this is the symbol for the two-way slab. Yeah, the symbol for the two-way slab, meaning that this direction and also this direction. 1 meter this direction, x direction, 1 meter y direction, represented by this symbol. Yeah? And then, yeah, and MSX1. MSX1 here is the moment at the span, while MSX2 is moment at the support. And MSY1 is at the span, and so for the MSY2. So we have 4 moments. Yeah? This is the one that we discussed just now. Okay, so since the question do not ask you to draw, then yeah, you can skip the drawing of the bending moment. Yeah. If sometimes the question asks you, then you need to draw the bending moment diagram. So now we calculate MSX and MSY. As shown here, we got 13.6 kilonewton, 18.2. Yeah, from here, you can see the calculation here. Okay. As I said, if the question asks you to do the drawing, just draw it. The value here, not the value here is, this is x direction, so 13.6. Okay. Then here is, what is it? 18.2. Okay. Do the same in this direction. Zero here, maximum, and something like that. Yeah. So you need to put the value here, 7.12 here, and 9.42 over here at the support. Okay. So you know, you already understand, yeah, how to arrange the steel. Then you can start with the design. Okay, all right. Now we need to find what is the d. So we have 2d here, dx and dy, right? What is dx and dy? Okay, as I mentioned last time, yeah. For the x direction, it is called dx. Yeah? When you do design at x direction here, this is x direction, this is Lx, yeah? This is x direction, 1 meter width here. So this is the cross section. The steel obtained from the moment at x direction must be located near to the bottom face. Yeah? Yeah? So the d will be called dx. Yeah? Dx here. It is equal h minus c minus diameter x over 2. When you design at y direction for the middle span, yeah, we talk about design at the middle span of the slab. Yeah? So we have y direction here. When we design moment at y direction, so we need to use dy, h minus c delta x minus diameter y divided by 2. Yeah? Okay, that is only at the center of the slab. So this is the slab moment at the span. Remember that, only moment at the span. Yeah? Okay, and show. Okay, that's why here we got dx and dy. This is to design the moment at the middle span here, MSX and MSY1. When we design MSX1, we use DX. When we design MSY1, we use DX, DY. Yeah? Okay. Here we use DX, while MSY we use DY. Okay. So for the moment MSY2, MSX2, it's only DX, D or D. Yeah, this is the normal D. D only. Okay. What is D? Is equal H minus cover minus diameter steel divided by 2. This is also the same. Use the same value. So you can see that D here is equal to DX. Okay, now we calculate the DX and DY. So we have DX 120, DY 110. Okay, then calculate the minimum and maximum reinforcement. Yeah? So the minimum, yeah, using the same formula as the beam. So you got here, what is it? 160. Yeah. So you got 160. So then we need to refer to the table given in the your guidance, your guideline here. The design formula. Okay, now we have here. Okay, look at table B. So our diameter is 10. Yeah. So we have 160. No 160 in the table. So you can choose what the S is equal 300 262, or you can change to other value. Also can. Yeah. So but in a question asks you to use 10. Yeah. So in the final exam or in the test, just use the diameter that the question asks you. Yeah. So now we have 300. Yeah, because in the table it's only 300. Okay. Right. That is the minimum reinforcement or secondary bar. This is what the secondary bar is actually is to cater for the torsion. Yeah? Torsion. Just now that we discussed, to avoid torsion, so we need to install secondary bar. Right. Then we proceed with the short span. MSX. Just now we have 13.6. So in order to design MSX, we need to use DX. Yeah? So our DX is 120 and the B is 1000. Yeah? So don't put 4000. Yeah? Don't put the value of LX, but 1000 because we design it now using 1 meter width. Yeah? So we have here compared with the K balance 0.167. So we got Z is greater than 0.95. Therefore, we use 0.95 in the calculation. So we have 274. So for 274, look at the table here. 274. Okay, 274. Okay. We miss here 275. Yeah. Okay, don't worry if you are in the final exam and in the test, just put 250. Yeah, 250 here. What is the value for 250 just now? 274. If 250 is 314, so we use 250. Okay. Right. So you have 314. Greater than this and greater than the minimum value. Yeah. So your value here 274 is greater than the minimum, yeah, which is okay in the range. Then based on the table, you got H10 to 50. Then at the support, remember at the support it is D. Yeah, we must use D. Whereas the value of D here is equal to dx. Yeah, this is D actually. Yeah, this is not dx, but in this case D is equal dx. Yeah, so D is equal dx. Sorry. D is equal dx. Okay. Therefore, here we use dx. Okay. Using the similar procedure, then we got 367, and then the value here must be compared with the minimum value. Yeah? Minimum value here, our minimum value is 160, so it's greater than okay. And then again we need the area provided 367. Refer to this table again. 367. Oh, you can use 200. 367. You can use 200. 200. Okay, is greater than 367. Okay, long span. Remember just now long span MSY. So we need to use dy here. Dy. Okay, 1000 and dy. So we got here 157. Okay, 157 is less than the minimum value here. Okay, therefore we must find the provided steel based on the AS min. Yeah. Okay, now we have this is less than AS min. Okay. Sorry, less than AS min. Okay, then what we need to do is that go to this table, find again 160 is, so we have 300, 262, 262, 300, change to 300 here. Okay, erase this, right? Okay, now we have 262, 300, and at the support, yeah, similar with the MSX at the support, we use D, yeah. Okay, now we have 190, and when we compare with the minimum, it's greater than the minimum. Therefore, the final provided steel must be based on the one that we obtained from the calculation here. 190 again, it is 300. Yeah, so it's 300. Yeah. Okay. Right. Top. What do you mean by top? It will be located at the top. Yeah. Okay. So meaning that now we can imagine we have obtained the steel. Yeah? So you know this is the main steel. The main steel that you have obtained here is H10 to 50 at the middle. H10 to 50. Okay, this is, let's say this is LX, yeah. This is span LX. LX, okay. at the support we have H10 200. Yeah, at the support we have H10 800. So at the support, see now at the support here. Okay, at the support. Okay. That is H10. 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 What is the value just now? 200. Yeah, 200. 200. Top. Yeah, that is called top. That is why we call it top. Because we put it at the top, near to the top surface of the concrete. So we call it top. Here is called bottom. It's bottom. Sometimes people call bottom. H10. H10 to 50. Yeah. Bottom. BOT. Bottom. This is H. Okay. So therefore, from the design here, we can imagine this is the kind of arrangement that we have. Yeah? And then, okay, after you got the Y here, MSY. Yeah, we got MSY at the midspan. So the value H10 300 will be located here, okay, on top of this. Something like that. Okay, so this is the steel from the Y direction. H10 300 bottom. That's why here it's stated bottom here. So the yellow one there is also H10 300 bottom. Yeah, bottom. So that's why we call it bottom. Okay. So this one is the steel. In Y direction. So when we look at the cross section LX, so we see that the steel at Y direction in a dot form. Okay. Okay. How about the MSY here? Yeah. Here we cannot see. Yeah, because this is cross section of LX. Yeah. Cross section of LX. What you see here is the cross section of LX. This cross section. This cross section. Therefore, we can see the MSX2. Yeah. The value is H10 200 at the top. MSX1 here, H10 to 50, and MSY H10 300. If you want to see the MSY2, so you need to cut here, this direction. Okay, so don't worry about that. Someone want to join, I think. Amalina want to join. Okay. After we finish design of the main steel, yeah. Okay, I forgot just now. This is the main steel that we obtained. Yeah? Okay, this is main steel that we design is main steel, but we need to provide minimum steel as well. For example, this which color should I use? Okay, pink one here. Okay, the steel at at the support, there must be accompanied by secondary still. Okay, yeah, the pink one. So this is AS min. Yeah? This is using AS min, secondary still, that we obtained earlier on. Yeah? Secondary still. Okay, this is secondary still, the pink one. Okay? Just to accompany the main still here, to avoid cracking. Okay. Now after we complete the design of the moment, the next one is is only checking, checking for the shear. Okay,
Doktor,
yeah.
saya nak tanya yang support MSY tu kan yang kat atas, kenapa D tu dia guna 120 ah?
DX, gunakan DX. D dia memang satu aja.
Oh memang sebab kan kat situ dia tulis support MSY kan, tapi kat situ D tu dia tulis.
Bukan macam tu. Dekat support sini ni, ya, dekat support, kalau you tengok kan dekat support, the D tu dari mana? D is from here to here kan? That is D. Or DX lah. D, bukan DX lah, D. It is actually D.
Terima kasih doktor.
Okay, so at the support, you don't think about dx or dy. Yeah? It is only d. What is d? D is equal h. Okay. D is equal h minus cover minus diameter bar divided by 2. Diameter bar. This is diameter bar. So that's it. That is at the support only. MSY and MSX2. Yeah? So in here, it is coincide. D is equal to dx. If you can see that it's actually equal to dx. So maybe you confused with that one. Okay. So now we continue again. Yeah, shear. So shear, as usual, you need to find what is shear. Shear, everyone already know how to obtain the value. Yeah. So only take the highest value. Normally, the highest value is at the x direction. That is 29.8 here. Here, the highest value. Okay. So we got 29.8. Then we check whether our the design shear force here greater or less than the design shear stress in the concrete. So we have in the concrete we have two. Here is the VRD max. VRD max is the concrete resistant for shears, and this is the formula for the slab. So just insert the value obtained from your design. Let's say now you have ASL. ASL is 393. So you got 58, and another one is that concrete also produce minimum shear force. Using this formula, we got 59.8. So between these two, this is the lowest one. And even the lowest one is greater than the shear force that we designed here. Therefore, our slab is, safe from the excessive shear force, shear stress. Therefore, okay, meaning okay here is our BED is much less than the BRD here. Okay, deflection. Deflection only check for the LX direction only. So we have here the direction of LX. What is the AS? AS for the span. So let us check. This is short span. We got 274 at near of span, near end middle span, yeah, 274. So just put it the value here. So you got 0.3, then calculate the rho naught. So we have the L over the basic. K for the slab is 1.3, yeah, because it is continuous. Yeah. We have here 71.52 compared with the actual 33.3. So it is okay, free from the excessive deflection. And then for the cracking, we have two, the main bar and secondary bar. So for the secondary bar is 3.5 H, yes, or 450. So we have 450 because 3.5 H is greater than 450. Therefore, our maximum bar spacing for the secondary bar just now is 300. Then it is less than 450, allowable. And also for the main bar, it is less than the S max here. Okay, 3H. Alright. After we complete all, we need to arrange the steel. Yeah? I need to erase everything. Okay. Okay, for the detailed drawing, we did a plan, yeah? Just like in the one way slab. We did a cross section and also the plan. This is the plan. Okay, the plan. We use number here because this is that we obtained just now. Our reinforcement is that top bottom that we obtained just now. This is 0, 1 is the X direction. This is X direction. X direction, yeah. X direction. This is 200 is the, let's check here. Still we have 250 and then 200. Okay, X direction as well. X direction at the support, yeah. Direction at support, top. Okay, top. This one bottom. It's better to put back bottom. X direction, but bottom. Okay, so we name it as 0, 1. Yeah, 0, 2 is for the X direction, but at the top. And then 0, 3 is the 0, 3 Y direction. Y direction, bottom. Okay, it's easy for you. Okay, then here is Y direction, top. Okay. Okay, now 0, 5. 0, 5. Where is 0, 5? 0, 5. 0, 5. Secondary reinforcement. Yeah? 0, 5 is secondary reinforcement. Secondary secondary steel, yeah. Okay, 06. 06 is, where is 06? 06 also secondary reinforcement. Secondary steel. Then 07. 07, where is 07 from the 07? Okay, 07 is for the torsion. 07 is the secondary as well, but it scatter for the torsion. H08. H08. It's look complicated, yeah, but it's not that difficult. Also secondary, and for the torsion as well. H10. Okay, 09. What is 09? 09. 09010, yeah, 09010 also for the secondary and torsion. Okay, now, okay, the first thing that you need to draw is draw the plan, yeah, draw the plan, the empty plan, something like that, and then draw the cross section, yeah, the cross section, whether cross section X or Y. Here we show it. Here is Y, because this is Y direction, so meaning that we cut here. We cut here. Now AA here. Yeah, this is AA. The cross section AA. The cross section AA you see here. This is AA. Okay, since this is the Y direction, therefore, okay, you need to show the steel, yeah. Look at here, 01. 01 is, what is 01? Is X direction at the bottom. Okay, if you see the dot only, yeah, because this is X direction, yeah, X direction, and you see it from the Y direction. So it become dot, okay, and on top of it is the 03. 03 is the Y direction main steel, Y direction here. Okay, main steel that we designed just now. We have 4 steel, right? So this is the steel at Y direction at near of middle span. Okay, and here at the support here is actually obtained from the MSY. MSY we obtain, MSY is this is 04, MSY 04. This is MSY. This is MSY. MSY 2. Yeah. This is MSY1, yeah. This is MSY1. Okay. This is MSX1. This is sorry. The MSX2. Okay. Okay. Here you can see here 04. This from the MSY2. Put over there near to the top surface, and it will be it is accompanied by the dot steel. There is actually secondary steel, yeah? 05 here, secondary steel, yeah. Secondary steel. This is secondary steel. Okay. And then since this is restraint slab, yeah, so you must provide steel here. Okay, you can see here this steel, yeah. At the top surface here, you can see there is number 9 and 10. So what is number 9 and 10? Number 9 and 10 is the secondary steel. Yeah. What is secondary steel? The spacing is 300. Yeah. Both direction. As you can see here, both direction. Slab. Okay. Even you can see here at the top surface we have 0, 9 and 10. So this is actually for the torsion. So how about the distance here? Yeah, the distance here and the distance here. How to get it? So in that case, we need to refer to the design formula booklet. So here, okay, detailing for rule for slab. Okay, here the provision must be within the length of 0.2 L. Yeah, 0.2 L. So 0.2 L. 0.2 L, 0.2 times 7,000 is equal 1,400. So this is 1,400 is equal 0.2 L. Obtained from the here. Sorry, here you can see here. Ni nilai ni 0.2 L. Sorry. Here. 0.2 L. Okay. And another one is at the continuous edge, it is 0.3 L. Okay, remember that 0.3 L. Okay, go back to our here 0.3 L. 0.3 L, yeah, 0.3 times 7. So let us calculate. 0.3 times 7. So you got actually 2100. Yeah, 2100. 2100. Okay. From the surface of the beam, you can see here is from the surface of the beam. It is from the surface of the beam. 0.3 L from the surface of the beam. 3 times 7, 2100. Therefore, go back here, so you can see from here to here is 2100. 0.3 L is equal to 100. Right? Also both sides. Let's say the beam, the size of the beam 50. So you can get 4450. Yeah? 2100 both sides plus with the width of the beam. So you can get the length here. Okay, so this is cross section at LY. Yeah. Well, for the X, yeah, if you want to draw both, yeah, it is also can, but I think one cross section is enough. Yeah? And then once you establish the cross section, so you can, project it to the plane. Yeah? Therefore, here, okay, I want to make it smaller. Okay, go to the okay, do that. Okay. And show to make it bigger. Now we already complete this one, cross section, and then what we need to do is that project it one by one to the plane. Yeah. For example, 0, 1, 0, 1, you can see the dot here is actually must be draw 0.1 here. From here to here, you can see here from here to here. The distance is one cover from the beam here. Okay. Actually, there's a lot of steel. Lot of steel. This, but we only show one of them, represented by this one, and then you indicate that is the steel, right? From here to here, yeah. This is the steel. You need to indicate like that using the circle, this one. And in the cross section, we see them dot like this. This is 0, 1, yeah? And put the name here 0, 1. Okay. Okay. 0, 3. 0, 3 is due to the moment at the y direction. Okay. 0, 3. I will change the color. Okay, is actually must be located from here to here. Sorry, just from here to here. Okay, one cover from the beam, one cover from the face of the beam. Okay. Then the steel must be shown, yeah. So the steel is here, the green one. Okay, something like that, and indicate the steel by putting the circle here and put the name 0, 3 here. So meaning that it is there will be a lot of green steel over there and red steel at the bottom face. Yeah. Okay. Then, okay, yeah, this can be projected up there. So what else do we need to project? Is that 0, 4. 0, 4. What is my symbol? 0, use other color. Pink. Okay. Okay. 04. 04 is the main steel. This is Y direction due to moment at Y direction. Yeah. Here. Okay. So we need to arrange from here to here. The distance is 4450 just now. So this is, we got a lot of steel, yeah. But now we need to show only one. Yeah. Okay. And then put a circle here, indicate that is the steel, and put the name 0, 04. Actually, it is 04. Oh, sorry. I made a mistake. Okay, I'm sorry, I made a mistake. Sorry. Okay, start again. This is the steel obtained from the design, the 04. It is from here to here, so we need to, project it. Okay, it must be laid, or provide from here to here, because this is to resist the moment. The moment happened at this, the beam, the moment here. Okay, so the moment, as you remember, the moment, something like that. Moment. So this moment must be resisted by this beam, this steel. So this is the steel. Okay. Therefore, the steel here, show one steel only from here to here, parallel to the moment. So this is 04. The name is 04. Okay. So don't get confused. Simple like that. And this steel must be accompanied by the secondary steel. It's called 05 here. 05. 05. So this secondary steel. Okay, the secondary steel must be from here to here. Why? From there? It must be follow the length of the pink steel here. Okay. Therefore, where is the arrow? From here to here. Okay. It must be located at the bottom of the 04. Okay. Now we have the steel. They'll show only one of them here. Okay. And indicate this is the steel. And put the name 06. Okay. That is finished for this part, and this part. Now this part, this part. How about this part? Okay. This is to avoid torsion. Torsion, if you can remember yesterday, according to the code, we must put something like. Here, we must provide the torsion steel, something like that, on top of the slab. Here also, but at the top face, dekat atas, not inside. No, it's only provided if there's a free edge to avoid it from the torsion or lift up. Okay, here because of free, so we need to provide the torsion reinforcement and torsion reinforcement here, torsion reinforcement over here, meaning that it must be the torsion reinforcement is actually it is like what do you call that? Like that, yeah. It must be two-way, like this. What do you call that? Grid, something like that. Meaning that you need to put the steel this direction, something like that, and also this direction, both direction. Okay, on top of near to the top surface of the slab. Yeah. Okay. Now I need to erase. Okay, erase everything here. Okay. Now, according to the simplified detailing, we need provide steel to at the top face with the distance 1400. How to get 1400? 0.2 L. With this 0.9 steel and steel name 10. Yeah, so this steel is the secondary steel actually. Yeah, it's similar with this 0.6. Therefore, the distance is 1400, similar with the steel. Okay, so we need to provide from here, yeah, from here to here. So you need to project this up there. 1400 ni, yeah. 1400 you need to project here. And just from here to here, we got a lot of steel. And then show only one from here to here. Yeah. In the theory, it's said that the torsion must be provided at the corner only, but in the simplified detailing, we need to continue the secondary steel here to avoid torsion from here to here and from here to here. Along the edge, along the free edge, must continue along the free edge. Let's say we consider this one first. So this is the to avoid torsion about this place, and also 0.9, and the 0.9 is from to accompany this way. We need from here to here. Okay, with the steel. Dot here to represent the steel, dot here, and put the name 0, 9, and 10. 0, 9, and 10. Here is 10. Okay, so we complete with the this section here and here. How about this section? Yeah, this way, LX, at the LX direction. So remember, we design moment here. We got 0.5. Yeah? 0.5, again, we need to provide steel from here to here. Okay. So how do we get the, sorry, not that one. I need to change the color. I don't want to use the same color. I want to choose orange. Okay, orange. Okay, yeah, we have a moment here. Remember, moment from here to here, moment, right? Okay, so to resist this moment, we need to provide the steel. Okay, the steel is must be provided from here to here. Okay, sorry. The the moment must be provided because this is the moment, this direction. So the steel must be provided from here to here. Okay. Therefore, the steel must be parallel to this moment. Yeah? This is the main steel. Okay. So we have 0, 2, 0, 2 here. So make it here and name it as 0, 2. Okay. And this steel is the main steel, and it must be accompanied by secondary steel. The secondary steel with the color cyan here. Yeah, cyan. From here, yeah, from the end of this steel here to here and here. So the steel must be provided this way, yeah, to accompany this steel. Then you need to put the circle here and indicate the number 05. Yeah, this one. Okay. Therefore, okay. Now the length. How about the length? Yeah, the length of the steel here. How about the length here? This is 0.3L. Yeah, this is 0.3L. 0.3LX. So 3, 4 is 200. So 1200. 1200 is from here to here is 1200, and here to here is 1200. So that is 1200. Okay. The length of this similar with this, right? Just now is 0.3L, right? Okay. Now we complete at this edge, and then we need to complete this edge as well. Yeah? Okay, so this is torsion. Yeah? Torsion will happen here because this is free edge. Therefore, we need to provide the secondary steel similar like this, yeah? From here to here. Yeah? Meaning that I need to draw from here to here, and this is the torsion steel or secondary steel, we call it. Okay. Okay, we need both way. The other way is that from here to here, then the steel is this way. Okay, so you name it as 08 and 07. Okay, so that is the detailing for the two-way slab. A two-way slab for this type of panel. Okay, do you have any question? Ada soalan?